So we are going to go today over chapter 5, which is discrete probability distribution. We define classical probability from a probability experiment, which produces a sample space. So a sample space is made of outcomes that are randomly obtained from the probability experiment. A random variable is a function that will associate to outcome of a random experiment a probability. For example, when a coin is tossed twice, the random variable could be the number of heads. So in that case, it will be 0, 1, or 2. When you toss a coin twice, you can have 0, 1, or 2 heads. Those numbers are randomly obtained from the random experiment of tossing a coin twice. So the values that we'll obtain from a random experiment could be numbers that are discrete or continuous. When the values of a random variable are discrete, we call it a discrete probability random variable. If it is not, we can call it a continuous or non-discrete random variable. For example, the number of speeding tickets issued on a certain stretch of I-95 South is a random variable because you cannot tell how many tickets will be issued. If you toss a dime four times, the number of heads is a random variable. The number of passes completed in a game by a quarterback is a random variable. And the number of defective parts in a lot of 1,000 items is a random variable. So we are going to focus on this chapter of random variables. So when we associate two numbers obtained from a random variable, the probability of getting that number, we define what is called a probability distribution. In case of a discrete probability distribution, we can express P of x equals to x by P of x. A probability distribution has this property that it's a probability, so it's greater than or equals to 0 and less than or equals to 1. So it's always non-negative. And the sum of all the probabilities should be 1 for the same random variable. Let's consider the experiment of rolling a die and define a random variable consisting of recording the numbers that is on the die. So we get a uniform random variable in which the probability is the same, 1/6. We can make a diagram that represents the probability distribution. Let's consider another example here. A bag contains 3 red checkers and 2 black checkers. 2 checkers are drawn in succession and without replacement from this bag. Let X represent the number of red checkers drawn in 2 attempts. So we can have 0, 1, or 2. The probability that from the 2 attempts we get no red is 0.1. Exactly 1, either the first or the second time, is 0.6, and exactly 2 is 0.3. So you can observe that each of these probability is not a negative number, and then each of them is between 0 and 1, and the sum of the probability is 1. So it is actually a probability distribution. As we did for frequency distribution, we can find the mean and the variance of a probability distribution. To find the mean, we simply multiply each value by its probability and then add them up. That's the meaning of the sign sigma, which is the sum here. So that gives us the mean. And for the variance, we will square each value, multiply by the probability, add them up, then subtract the square of the mean. The mean variance and standard deviation should be rounded to one more decimal place than the outcome, that is the random variable x. When fractions are used, they should be reduced to lowest term. Let's look at this example of rolling a die. The random variables are values when we roll a die. The random variables are values 1, 2, 3, 4, 5, 6 with probability 1/6. To find the mean, we multiply each value by the probability. So 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. That will give us 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21, divided by 6, which is 3.5. Let's look at another example here. The probability distribution shown represents the number of trips of 5 nights or more than American adults take per year. That is 6% do not take any trips lasting 5 nights or more. And 70% take one trip lasting 5 nights or more, etc. Find the mean. So we have the random variable x has value 0, 1, 2, 3, 4. And associated to each of those values are the probability for those values. To find the mean, we multiply each random value by the probability of getting it. So we are going to have 0 times 0.06 plus 1 times 0.07 plus 2 times 0.02 plus 3 times, and we get 1.2. So that's how we find the mean of a random variable in a probability distribution. If you have a question, you can stop me at any time. Now, to compute the variance, what we will do is squaring each of the random value, like to get a new distribution with the same probability, and find the mean of the square. So we will have 1 squared times 1/6 plus 2 squared times 1/6 plus 3 squared times 1/6 plus 4 squared times 1/6, and so on. Then we are going to subtract the square of the mean, which was 3.5. So by doing so, we get the variance is 2.9. The standard deviation is always the square root of the variance is 1.7. Let's look at another distribution here. A talk radio station has 4 telephone lines. If the host is unable to talk, like during a commercial, or is talking to a person, the other callers are placed on hold. When all lines are in use, others who are trying to call in get the busy signal. The probability that 0, 1, 2, 3, or 4 people will get through is shown in the distribution below. Find the mean, variance, and standard deviation. So we have the probability distribution. The mean is obtained by multiplying each value by its probability and add them up to get 1.6. To find the variance, we first compute the mean of the square, that is squaring each value and multiplying by the probability, and then subtract from it the square of the mean. So we get the variance to be 1.2 and the standard deviation to be 1.1. So sometimes we use the word expected value or expectation to represent the mean, but it is still another way to call the mean. Look at this example. 1,000 tickets are sold at $1 each for a color television valued $350. What is the expected value of the gain if you purchase one ticket? If you purchase one ticket, you spend $1 for that ticket. So when you win 350, when you win a screen television worth 350, your net value, your gain is 349. If you don't win it, you lose your $1. Because 1,000 tickets were sold, the probability that you will win is 1 over 1,000. And the probability that you will lose is 999. So the expected gain is the expectation of this random variable we just defined, which is negative 0.65, meaning that you expect to lose 65 cents. Let's look at another a little more complex example. 1,000 tickets are sold at $1 each for 4 different prices: 100, 50, 25, and $10. After each prize drawing, the winning ticket is then returned to the pool of ticket. What is the expected value if you purchase 2 tickets? If you purchase 2 tickets, you have 2 chances out of 1,000 to win $100, $50, 25, or $10. And if you do not win any of those from your 2 tickets, you have 992 possibility of losing. So we can find a mean by multiplying each of the value by the probability and add them up until we will get negative 1.63. The value of $2 that we have here represent the cost of the 2 tickets. We could first subtract it from each of the price value before computing the mean. You can subtract it before or you can subtract it after. Life insurance. A person pays $100 for a 1-year term insurance policy. The probability that this person will live 1 more year is 0.97. The policy pays his beneficiaries $3,000 upon the death of the policyholder. What is the expected value of X, the amount of money the insurance company expects to make? So we are going to define X as the amount of money the insurance company expects to make. When there is no debt for the person, the company will make the whole $100 charge. And if there is that if the person dies, the insurance will pay $3,000, but it has taken a premium of $100. That means the insurance company will lose $2,900. With this probability, we can have that the company expects a profit of $10. Binomial distribution. There are many types of probability problems in which we have exactly 2 outcomes. When we have a sequence of trials, each trial having exactly 2 outcomes, it leads us to the definition of what we will call a binomial experiment. In a binomial experiment, there should be a fixed number of independent trials. Each trial can have only 2 possible outcomes: success or failure. The probability of success must remain the same for each trial. And the number X of success is called the binomial random variable. So the probability of success will be denoted by P, The probability of failure will be denoted by Q, which is 1 minus P. N is the number of trials, and X is the number of success. The possible number of success could be 0, 1, 2, 3, up to N, the number of trials you are going to make. Example, suppose there is a 0.3 probability that a customer works in a store and buys at least one product. Find the probability that 2 out of 3 customers will buy at least one product. So we can observe that this is an example of binomial experiment. The number of trials here is 3. Each of those trials has exactly 2 outcomes. Either the customer buys at least one product or the customer does not buy a product. The trials are independent because the 3 customers entered the shop independently. So what is the probability that X equals to 2? We can use the probability distribution formula that we will explain later to find this probability. So this is the probability distribution formula. This formula looks a little bit complicated, but you are not going to need it. If you can use a binomial distribution calculator for Google to do this computation, or you can use your TI-83 or 84 calculator. Let's look at this problem, and then I'm going to show you how to use your binomial distribution calculator. A survey found that 1 out of 5 Americans say he or she has visited a doctor in a given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. So here the number of trials is 10. The probability of success is 1 out of 5, that is 0.2. And we want the probability of exactly 3 successes. So N equals to 10, P equals to 0.2, and X equals to 3. So using this whiteboard, this was a binomial distribution with N equals to N equals to 10. P equals to 1 over 5, which is 0.2. And we want to find the probability that X equals to 3. With a probability like P equal to 0.2, there is a table at the back of your book, the binomial distribution table that you can use. We are going to go back to our point to use that. At this point, I'm going to use the binomial distribution calculator. I'm going to move to Google. And I will type here binomial distribution. I wanted to type binomial distribution, and it offers me binomial distribution calculator. The first binomial distribution calculator on Google is a good one. So it will ask you, what is the probability of success on a single trial? The probability of success on the single trial was 1 over 5, which is 0.2. And what is the number of trials? We recall it was 10. And now the probability quotient of this binomial distribution has X equals to 3. Then I click calculate. So the first answer is for X equals to X, that is X equals to 3. The second answer is for x less than 3. The third one is for x less than or equals to 3, and so on. X greater than x and x greater than or equals to x. You can use this binomial distribution calculator to answer several questions involving a binomial distribution. So as you could see from that, using the formula, we have 0.201. Let me get back to the binomial distribution calculator. You will see what we got. So this was the first, this is the first case, 0.201. A survey from Teenager Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. So here n equals to 5, p equals to 0.3, and we have a question about at least 3. That means x equals to 3, 4, 5. So we can either find, using the formula, the probability for each of them. This is at least 3, or x is greater than or equals to 3. Or we go back to use and then add the probability. 3 will be, at least 3 is 3, 4, or 5. So that's why we can find the probability for each and add them up. So the answer will be 0.162. Here recall that n equals to 5, p equals to 0.3, and we want x is greater than or equals to 3. I will use the binomial distribution calculator. So we had that p is 0.3. The number of trials was 5. So calculate with x equals to 3. So what we have as question here is x is greater than or equals to 3. This is greater than or equals to 3. So we will get 0.163. That's how we can use the binomial distribution table. As I told you, in your textbook, you have a binomial distribution calculator. For that binomial distribution calculator, if you toss a coin 3 times, find the probability of getting exactly 2 heads. So you will go on the first line here is the probability. So when you toss a coin, the probability of head or tail is 0.5. So for each of these nice probability, you can use this table. So they will be asking us to find the probability that x is equal to 2. For x equals to 2 here, n equals to 5. Here, n equals to 2. N equals to 3. So a coin is tossed 3 times, n equals to 3. So we have 3 here. Now we use this 2 here with the probability of 0.5 to get 0.375. So sometimes you can use that table, but because you easily have access to Google, you can just Google a binomial distribution calculator and use it to do the computation. Some properties of binomial distribution. How do we find the mean, the variance, and standard deviation? It's as simple as when you have a binomial distribution with n trials and probability of success p, the mean is mu equals to np. The variance is sigma square equals to npq, and the standard deviation is the square root of the variance. Example, the statistical bulletin published by Metropolitan Life Insurance Corporation reported that 2% of all American births result in twins. If a random sample of 8,000 birds is taken, find the mean, variance, and standard deviation of the number of birds that will result in twins. So the mean will be 8,000 times 0.02 equals to 160. The variance will be NPQ, which is 8,000 times 0.02 times 0.98. 0.98 is 1 minus 0.02. So we have PQ, NPQ. Q is 1 minus P. And the square root of the variance is 12.5, which we can round up to 13. So you can also use a TI-83 or 84 calculator if you like, and these are the way to find it. To calculate the binomial probability using the TI-83 84 calculator, go to second function, then you will see distributions. And from those distributions, choose option 10 or 11, depending on the nature of the problem. Okay. Example, you can use this example to practice. You can choose option. If you have an equation, find the probability that x is less than or equals to 3, for example, when n equals to 10, you will use the binomial CDF for less than or equals to. But for equal to, you use the binomial PDF, less than or equals to binomial CDF. So that is it for chapter 5. I don't know if you have any question. You can practice with doing your homework and making a first attempt of the quiz. If you have any question, contact me, and I will try to explain first by email. And if need be, we can meet on Zoom if you need more explanation.